ADO.NET is Microsoft's latest evolution of their various data access APIs. It doesn't replace, but it supplements all of the old APIs. Well, DBLib, it's ancient history. But ODBC, DAO, RDO, ADO, and all the other O's there are out there, ADO.NET works with those APIs to provide access to managed applications to your data. ADO does work great if you're thinking back to the old world of ADO, but it does require COM and Windows on both sides of the connection. Record sets don't travel well across the internet, and so if you're intending to use ADO to publish data on the web, you have a real problem. And the fact that ADO requires connected behavior to do most of its work, well, that's somewhat hard to work with, and ADO's support for disconnected behavior isn't fully thought out. On the other hand, ADO.NET, that is managed data access, requires a slightly different mindset. In ADO.NET, data access will most likely be disconnected. And all data transport, if it's required to transport data across the web or across a disconnected network, uses XML. Transparently, ADO.NET can serialize your data into XML and then deserialize it as needed. ADO.NET solves these particular problems. It uses XML under the covers for data transport, so getting data from one place to another is no longer a problem as it was using ADO. In addition, XML has no runtime or transport requirements, and this means there's no special code required to marshal the data across the internet. Anybody can read or write XML, any operating system, any code, so there's nothing special required to send a dataset, that is an ADO.NET dataset, across the wire to some remote location. ADO.NET provides a series of classes and namespaces for working with data. The root namespace is system.data. From there are a number of other namespaces hanging off of this, including system.data.oladb, system.data.sql client, system.data.odbc, which we won't cover here, and more to come. There's actually more already out. System.data.oladb gives you access to unmanaged data providers, like, well, the JET provider. System.data.sql client provides managed access to SQL Server data. You'll see examples using the OLADB namespace and the SQL client namespace. What are these? Well, the system.data.oladb library is designed for working with all OLADB data sources, like JET and Oracle and so on. Although, on the other hand, there is a specific ADO.NET namespace for Oracle provided by Oracle. Microsoft only provides the OLADB namespace for working with all OLADB data sources. It supports existing OLADB providers. And remember, these OLADB providers run outside the Common Language Runtime, so they're not managed code. The managed provider, that system.data.oladb set of classes, communicate with these unmanaged data providers that allow access to OLADB data sources. On the other hand, system.data.sql client is a managed provider that works only with SQL Server. So when you're using system.data.sql client, you're using all managed code to talk directly to SQL Server. This diagram provides an overview of how you might use ADO.NET to access data and provide a front end to your data, perhaps over the internet. If you look on the right-hand side, we have the data tier. The data tier is the home for the data. Some code has to know where that data is and what its exact schema is in order to be able to provide it to the middle tier and then the front end of your application. If we keep moving to the left, you'll see there's a business tier. The business tier generally needs a way to access the data, and so you'll find a tool called a data adapter here that knows how to communicate with the data tier. A data adapter will need to be data specific. For example, there will be a data adapter that knows exactly how to talk to your particular database, SQL Server, Oracle, JET, whatever. Each data adapter will know about a specific kind of data. The data adapter retrieves the data and provides it to some data agnostic caching mechanism for the data. The business tier's goal is to retrieve the data and expose it to the front end, the presentation tier. Now, the business tier could be located on a single machine. It could be several different networked machines, one perhaps retrieving the data and providing it to yet another. But from the front end's point of view, from the presentation tier's point of view, there's a business tier that somehow gets the data and provides the data for its use. Now, in the business tier, once you've retrieved the data, you need to cache it somewhere and provide it as a set of objects. ADO.NET makes this easy by providing the dataset class. A dataset contains one or more data tables. You can see those little blobs within the diagram. Each data table is a rectangular set of rows and columns. Each data table could be retrieving data from more than one real data table. For example, a data table within a dataset might contain information from customers and order details, all flattened out and displayed in a rectangular set of rows and columns. It's very important to understand that a data table within a data set does not necessarily correspond to exactly one table in the original data. The data tables within a data set can be related to each other, and you can see the little squiggly line in the diagram, and this allows you to have an in-memory relation between multiple data tables within the data set. Now, the business tier can expose that data set directly, or it can expose a set of classes that wrap up the data in the data set. But whatever the case is, the business tier provides an object which represents the data that the data adapter retrieved from the data tier. On the left-hand side, we have the presentation tier. And this could be Windows Forms applications, could be a WPF application, could be a web application, could be some application, maybe BizTalk. Maybe an old version of BizTalk that understands XML but doesn't really understand a data set. So in this diagram, that data set gets sent across the internet as XML, and the Windows application and the web application are both able to take that XML, rehydrate it back into a data set, and present that information in their user interface. Because we have managed code on both sides, in the business tier and the presentation tier, they both understand the layout and the structure of this XML, which represents a dataset. On the other hand, an application which knows nothing about datasets or managed code can still work with the dataset because it's just XML. It'll be a little more work. They'll have to take the XML and retrieve the data out of it. But they certainly can. Any application can work with a dataset that's been serialized to be sent across the internet because it's just standard XML. On the other hand, you should understand that if you're working with data on an intranet, it doesn't need to be serialized as XML. It can be sent across your local network as a real object. ADO.NET can determine how it needs to serialize the data, either leave it alone or save it as XML, and will do the right thing with the data depending on where it needs to send the data. We'll be looking at, in this section, using the various classes in ADO.NET to begin retrieving data from the data tier so that you can generate the business tier. We'll start by looking at the data table object, which is really the central data storage object in ADO.NET. A data table represents one table of in-memory data. It supports rows and columns with schema information like an array, a very fancy array. But remember, the data table can contain data from more than one physical table within your data source. It can have joined data or grouped data. Whatever the case is, a data table is just a rectangular set of rows and columns. You can retrieve, and you most likely will retrieve, a data table's data by retrieving data from a connection to some data source. Or you can create and fill the data table one row at a time. We'll start here. We'll retrieve data from the file system just to show how you can build your own data table without a connection if that's what your application requires. I've loaded the sample application for this section named Accessing Data, and I've run the application, which displays this form. I'm going to single step through the code, and I'll create a data table to demonstrate how you might write this code. If we look at the code, there's a few interesting things here. First of all, I'm using system.data. I have a using statement for system.data, so I can use the various items within that namespace without having to type system.data every time I want to use one. Now within our code here, I'll call the create data table procedure. And here we go. And the first thing we'll do is create a new data table. A data table comes from the system.data namespace, and it really knows nothing about its data source. It's just a container for some kind of data. And in this case, we're going to specify that data here. So we'll start by creating the new data table object. Now right now it's just a blob of protoplasm. It has no structure yet. We need to add the structure to this data table. And the way we do that is by adding to the columns collection of the data table. Right now, columns collection is empty. So when you add to the columns collection, you specify the column name and its type. Here we're using the type of operator in C#, given a type, to return a type object that represents that type. So here we're adding a new column named file name that will contain strings, and a column named size that will contain long integer values. So right now we have added 2 columns to our data table. I'm going to fill in data using a data row object. A data row is an object I'll add 1 row at a time to our rows collection in the data table. So I'll create the data row first, and now I'll create a directory info object. The directory info object comes from the system.io namespace, and here we can specify just a path, and we'll get directory info about that path. So at this point, after running that line of code, dir refers to a directory info object with information about c:\\. Now we're going to loop. We'll use a for each loop and have each file info object in the getFiles method of the dir object. So the directory info object provides a getFiles method, which we can use to retrieve a list of all the files in a particular folder. Each one of those will be a file info object, and so this loop will visit each one of those file info objects in turn. So for each file info in the getFiles method, we're going to add a new row. Well, actually not add a new row, but create a new row and have dir, our data row variable, point to it. So dir now isn't in the data table, it's just a freely standing data row object that's created using the schema from our data table. That's why we call dt.newRow. It hands us a data row with the correct schema. Here we'll set the 0th column's value to be fi.name, the name property of the file. We'll set dr, the second column in our data row, to be the length of the file. So we have now a freestanding data row object. We need to add it to the rows collection of our data table. So it's like taking a little Lego and snapping it onto the collection of Legos that we have already started. We'll add the row to the collection of rows in our data table. We'll repeat that for each item in the collection of files. Finally, once we're done, we end up here. And the last step is to set the data source property of our grid to be that data table. By setting the data source of the grid to be that data table, we'll display its contents with just one line of code within our form. If I press F5 to run, you'll see we've displayed within the grid view all of the files in my c:\/ folder and their sizes displayed automatically within the grid. So although this seems like a little bit of a made-up example, it's useful because should you ever need to retrieve information from somewhere that isn't part of some data source and you want to display it in a grid, easiest way to do it? Create a data table, fill in the rows in the data table, and then bind the data table as the source of a grid control, and there you are. You can see you can display the data automatically within that control. If you actually want to work with data from some data source, you'll need some way to connect to that data source. And each of the data namespaces provide their own connection object. There's the OLEDB connection object, which can connect to OLEDB data sources, and the SQL connection object, which can connect to SQL Server data sources. Now, it's tempting to go looking for a connection object in the help for .NET, but you won't find it. There's no connection object. There's OLEDB connection and SQL connection. I'll refer to these objects as connection objects, but really, there is no connection object. Just like I said, I'll refer to them as connection objects, and here we go. Connection objects provide various constructors which allow you to pass a connection string or other information at the time you create the object. For example, you could specify the initial catalog, the data source, whether you want to use integrated security, all as part of the constructor for your connection. The SQL connection object has additional overloads where you can pass user information and data source information as individual parameters. This makes it a lot easier to create a connection to SQL Server without having to type in a long connection string, if that's what you want to do. When you create a connection string, generally it's stored in some sort of configuration file. You can deploy this configuration file with your project, containing configuration information about your project, including connection strings. If you use the project settings in Visual Studio, you'll end up with something like this in your configuration file. You have a connection string section, and within there you have add elements with a name for the connection string and then a connection string itself. For SQL Server, that connection string will include a data source, initial catalog, most likely integrated security settings. And then for an OLEDB connection string, we have a second add element. In this case, the connection string includes provider name and a data source with a path that leads you directly to a JET database you'd like to use as part of your OLEDB data access. Now, once you've set up the connection, you need to actually write code to retrieve the value. You can use properties.settings.default. and then retrieve the name of your setting from the settings file. This code shows how you might store it into a local variable for use within your application. Let's see how to use Visual Studio's tools to create a connection string within the configuration file. I'll right-click on the project and choose Properties. Within the Properties dialog, I'll choose Settings, which was already chosen for me here. And I'd like to create a new connection string. I'll come here and type my connection string. And in the next column, for type, don't choose string, because that would place it in the wrong position within the configuration file. I'm going to choose connection string, so we know it's a connection string in the configuration file. Notice that that changes the scope to application, and we can't change it because connection strings are always application resources. I'll click the button on the right-hand side here and use this dialog box to create my connection string. I type ./SQL Express for the server name. Your server name might be something else. I'm using the SQL Express instance on the local machine. I could choose a different kind of authentication. I can choose the database name, which is Northwind. I'll test the connection to make sure it's okay, and click OK. This generates the connection string for me, and it looks like the other connection string I already had. It is. It's the same exact thing. So now, how do we use this connection string? Well, the first thing we need to do is put this away. When I put this away, it saves my settings, and now in my configuration file, we should find that new connection string here named my connection string. Let's write some code to access that connection string. I'll go to my Solution Explorer, just open up some piece of code here. And in here, let's just write the code. So we could say string connection string equals properties.settings.default.my connection string. And that's it. We're done. We've retrieved the connection string that we created from the settings file that goes with this project. I don't need that code, so I'll remove it and put this away. So you've seen how to create the connection string. Now let's see how we can actually use the connection string. To connect to data using SQL Server or OLEDB, you might write code like these two little code snippets. In the first one, we're using an OLEDB connection and the connection string we retrieved from our configuration file. Once we retrieve that connection, create it, we need to open the connection, and we use the connection. When we're done, If that connection isn't null, we need to close it. You need to make sure you always close connections when you're done with them, because there aren't an unlimited number of connections, especially on SQL Server, where you might be licensing the server by a certain number of connections. You can do the same thing for a SQL connection. You create the new instance of the SQL connection object, you open it, you use it, and when you're done, you close it. Now, we probably should include some exception handling, which means you might want to write code like this. We create the SQL connection object and then instantiate it by calling its constructor, passing in the connection string. We open it. We do that inside a try block. Should something go wrong, we'll automatically jump to the finally block, and in the finally block, if that connection isn't null, then we'll close the connection. This way, we're guaranteed that no matter what happens, that connection gets closed. Now, there are alternatives to doing it this way, and we'll look at those in just a moment. But as a first pass, this is a reasonable way to solve the problem of ensuring that your connection gets closed whether or not something went wrong while it was in use. The using block actually makes this sort of thing easier. The using statement automatically disposes the object that it handles when the block ends. For connections, that means the connection is closed as well. The best practice is use the using block if the object you're working with implements the iDisposable interface, and certainly the connection objects do. Same thing goes for commands we'll look at later, and data readers as well. They all implement iDisposable, and therefore you probably should use them with a using block. If you do that, you don't need to use that finally block thing to ensure that you actually dispose of the object when you're done with it. The using block you create might look something like this. Using a new SQL connection, passing in the connection string from the configuration file into the constructor, then open the connection and then use the connection. At the end of the using block, the connection will automatically be disposed and therefore will automatically be closed as well. You don't need to even add code to close it yourself. The using block will take care of it for you. Adding the explicit code to close the connection would be actually somewhat redundant. So the code you write would look something like this. Using block is a great tool because it makes it explicit what's going on. You're using the object and then disposing of it at the end of the block. If you go study the intermediate language that gets created for you when you write code like this, you'll see that they inject the finally block for you. But in this case, we don't need to worry about it because in C#, the using block causes the connection object to be disposed of when the block has completed. You've seen the connection object, but it really doesn't get you very far towards working with data. You also need some way to indicate to ADO.NET what you want to do with the data, and that requires a command. The data namespaces expose a command object that allows you to execute provider-specific commands, SQL statements that retrieve data. There's a SQL command object, there's an OLEDB command object, and more as well, one for each of the various data namespaces. These usually are made up of SQL statements or references to stored procedures that execute some command and either return data or just do some work on data. These objects expose different overloaded constructors that allow you to pass in different bits of information at the time you create the command object. And commands can do several different things. Commands can return data back to you. They can just execute actions, delete all the rows from a table, insert a bunch of rows into a table, that sort of thing. Or they can return a single data item. The command objects include a method that allows you to return just a single data item back. It's an efficient way to get an answer to a particular question, like, how many customers are there in Texas that ordered more than 50 items in the past 5 years? Get that answer back using a command. In order to take those actions, the command object provides a number of methods. For example, execute reader. The execute reader method executes some data search and returns a data reader back. It could be as simple as select star from customers, or it could be a complex expression that you're returning back the data, and a data reader provides forward-only, read-only access to the data you retrieve. Execute non-query which is a very bad name because execute non-query does execute a query, it just doesn't return anything back. It should be something like execute without return value, but in any case, it just executes a statement and doesn't return anything at all. You would call the execute non-query method to execute something like delete star from some table. Execute scalar executes a query and returns the first value in the first row of the reader that would have been returned. So it doesn't actually take the effort to return a bunch of rows back, even a whole row back. It just returns the first column in the first row it would have returned if it was returning multiple rows of data. So it lets you get at a single piece of data in an efficient manner. If you want to work with data, you need some way to get handed back a set of data, and that's what a data reader is for. You'll find the system.data.sql client.sql data reader and the system.data.oladb.oladb data reader and others in other namespaces as well. This is analogous to a forward-only, read-only, server-side ADO record set. If you're moving up from ADO, that should be familiar. A data reader is designed to fetch records from the data source in a stream as quickly as possible. There's very little overhead in a data reader because it's only sending one row at a time back to your client code. Of course, it's caching data, so it's doing it efficiently. It's not like it's getting a row and going to sleep until you ask it for another one. It's caching the data but providing it to your application in one row at a time. It's important to note that data isn't cached on the client side. That is, your application has no mechanism using a data reader to automatically retrieve 10 rows and move forwards and backwards within those 10 rows. You can do that using a data set. We'll look at that later. But for a data reader, the whole point is all you want is one row at a time to do something with that one row at a time. The data reader object isn't creatable. You'll never say, create a new instance of the data reader. Instead, it's returned as the result of executing an appropriate method of a command object. You really need to close the data reader when you're done. Otherwise, your connection object won't get closed and you'll be leaving a connection open. Now, there is a new feature that came with SQL Server 2005 and SQL 2005 Express that makes this less of a problem, called MARS, Multiple Active Result Sets. Before this feature, a single connection could only provide a single result set. Using MARS, a single connection can retrieve multiple result sets concurrently, but it's only useful if you're using 2005 or later, and it's still a better idea to close the connection when you're done. There's one problem we haven't discussed. Now, if you're using a using block in your code and you know when it's time to close the connection, this isn't a problem. But if you're handing a reader to some other assembly and all they have is the data reader, you need some way to close the connection when they're done with the data reader. The way you do that is passing the command behavior.close connection as a parameter when you execute the execute reader method. This says that when you're done with the data reader, and remember, if you're handing a data reader to some other assembly, they don't have access to the connection. When they close the data reader and you've used this option, when they close the data reader, the code will automatically close the connection as well. You only need this if you're handing out a data reader to some other code which won't have access to the connection object. In that case, by specifying this parameter, you can be assured that when the user, when the consumer of the data reader is done with the data reader, that the connection will also be closed. Let's look at an example that uses a data reader to retrieve data from SQL Server. In our sample, I'll single step through the code and choose the SQL Data Reader option. This allows us to step into an example that shows off the SQL Data Reader. We'll start by creating a SQL string. Mine is select star from employees. Yours might be more complicated. Inside a try block, well, why is there a try block if we're using the using block here? Because it's always best to catch any errors that might occur. In our case, we'll just display a message box should something go wrong, because when you're working with data, it's likely something will always go wrong. In this case, however, it probably won't. Here, we have a using block using a SQL connection object. we'll get the connection string from our configuration file, there. Given our connection object, we'll create a new command object, and we'll pass to the constructor of the command object the SQL string, which was select star from employees, and our current connection object. We haven't opened the connection yet, but we need the command to know where to get its data from. So there we go. Here I've stepped into the code to retrieve information from my configuration file. Didn't need to do that. There we go. And now we're going to set up our command object. We need to open that connection before we execute the reader, which we'll do now. The execute reader method hands back a data reader, and we'll use that data reader inside a using block, so when we're done with the data reader, we will automatically dispose of it. So dr is our data reader in this case. Now we're going to loop through all the rows. The trick here is the read method of the data reader. Well, let's step back. The data reader starts automatically positioned right before the first row of data. The read method then moves us forward a row and returns true if it successfully read a row and false if it didn't. So you can use a while loop to continue reading as long as there continue to be rows. It's a very simple mechanism, and it avoids the problems that you might have had with ADO record sets where you forgot to call the move next method and you'd never move forward a row. Here that can't happen because the read method of the data reader will always move you forward a row. Now inside this loop, we're going to retrieve data from the data reader. There are a number of different ways to retrieve the data. In our case, we're doing it by index, which is the name of the field. Now this isn't very efficient because it causes the data reader to have to look through or scan all the column names for each column we need to retrieve, and it does it for each row. You might get better performance using an ordinal value, that is the position of the column, or one of the get methods like getString, getInteger, and so on to retrieve data from a specific column in the data reader. For now, we're not concerned about efficiency. We're just trying to get the data in a readable way. So here we'll loop through all the rows, and for each row, we'll add a formatted string to a list of items on the form. Well, that's all the code does. At the end of each of these blocks, we dispose of the corresponding object, and then when we're done, we display the information in this list box. Using a data reader is a great way to efficiently retrieve data for use in any control where you need to add items one at a time from some data source. We had alternatives here. We could have filled a data table with the data and then bound the list box to that data source, but we haven't gotten to data table filling from a connection yet. So we've added items one at a time from a data reader to this list box.